So here's your problem, and I think you cross multiplied. I hope you did. Hope you did that. And remember the reciprocal. If you have 3 over 5 and you multiply it by 5 over 3, it takes care of all your problems, but then you have to do it to the other side. Okay, finding a base. Let's see. This is like what we did with the bell work. We used a proportion, right? Well, let's see. I mean, we can use, that's how I'm going to do it. So 125% of what number is 17.5? So what does 125% look like? 125% looks like 125 over 100. Anything over 100 is a percent. So if I say 125%, if that's what I have, well, hopefully right away in your mind you're thinking that must be over 100. And I'm going to compare it to some other situation. So I'm going to say equals, because that's how I compare. So let's see. 125% of some number is. So the of, you know how I like to look at the word of? Yeah, that's something that it says what number. It's asking me. But I know that if I have 17.5, that is 125%. It's the same thing as 125 out of 100. So obviously 17.5 is going to be bigger than the number, because 125 is bigger than 100. So let's see here. We're going to say 125 times n is equal to, I know they didn't do it like this on their problem, but then I have 17.5 times 100. I'm going to move that decimal point over twice because it's 2 zeros. And I'm going to get 17 with 5 and 0. And then I'm going to pick up my calculator, because what's coming next is I'm dividing both sides by 125. If it's 125 times n, I'm going to divide by 125, right? So let's see here. I say 1750 divided by 125, and I get, oh, it's 14. So n is equal to, the 125s cancel, right? N is equal to 14 when I do this division. Which division? This division. That's a division problem right there. Okay, so that's my answer. N is 14. And, oh, look, that's what they got. In their way. Maybe you like their way better. But I really like proportions, and we're using proportions a lot anyway. I feel like that's a great thing. So there's your example.